Hello everybody, today we're going to talk about some applications of quadratics. There's 3 examples. We're going to talk about maximum height, where an item is launched, how long it's in the air, and those types of things. Alright, our first one here is a toy rocket. It says a toy rocket is launched straight up from the top of a building. The function that models the height as a function of time is h of t equals negative 16t squared plus 200t plus 50. Got a couple questions to answer here. At what height was the rocket launched, and at what time did the rocket reach a maximum height? Okay, let's just kind of look at the function for a minute. This is a parabola, and because our a number is negative, it's going to open down like that. The vertex and the y-coordinate of the vertex will answer a couple questions. It'll answer how high it reached, but that's not what it's asking. They want to know what time it reached. So when we look at the xy plane, it's really like instead of the x-axis, it's the t-axis for time, and the y-axis serves as h for height. So this kind of shows us the height of the rocket. To answer the first question, at what height was the rocket launched? Well, the rocket was launched at time 0, t equals 0. So all we need to do is put a 0 in for the function. Alright, negative 16, 0 squared is 0. 200 times 0 is 0. But then we're just left with the 50. So that right there is going to tell us how high the rocket was when it was launched. 50 feet. That's how high it was when it was launched. Alright, that would also correspond to the y-intercept here at 50. And then at what time did it reach its maximum height? We need, this happens here at the vertex, and it's the x-coordinate of the vertex. The x-coordinate of the vertex, or in this case the t-coordinate, will tell us that. Remember that formula for the vertex, the x-coordinate negative b over 2a. Well, our b number is 200, our a number is negative 16, and our c number is 50. Negative b would be negative 200, and 2 times a is 2 times negative 16. So it's a negative over a negative is a positive, so it's basically 200 divided by 32, and that's going to equal 6.25. So the rocket reaches a maximum height at 6.25 seconds. Let's look over here at Desmos. We'll look at this thing so you can see it. Here's our first function right here. There it is. Negative 16t squared plus 200t plus 50. And if I click here, there it is, 0, 50. That's where we launched from. Here's our vertex. Tells us if we wanted to know, if the question asked how high it went, we could answer that. 675 feet. And notice it's happening right here at 6.25 seconds. Alright. So yeah, always check your work on Desmos. Give you a good idea how the function itself looks. Another situation. One of the games at a carnival involves trying to ring a bell with a ball by hitting a lever that propels the ball into the air. The height of the ball is modeled by the equation h of t equals negative 16t squared plus 39t. If the bell is 25 feet above the ground, will it be hit by the ball? Okay, so it's basically asking how high will it go? What's the maximum height that will go? And if we can determine that maximum height, then we can answer the question. Is it 25? Is it greater than 25? Less than? Equal? Is it going to be hit? If it hits that 25 feet mark, it will be hit by the ball. Let's find our vertex. Or the vertex, the x-coordinate of the vertex, negative b over 2a. In this problem, we have a, b, and c. C, don't need it, but it's actually 0. Negative b would be negative 39. 2 times a would be 2 times negative 16, which is negative 32. Negative over negative is a positive. 39 over 32 equals about 1.22 rounded. Now, to find the actual height, we've got to take that 1.22 and plug it in for t in our function. So we're going to have negative 16 t squared, which is in this case 1.22 squared, plus 39t, which is 39 times 1.22. All right, and that's going to come out to approximately, rounded, plugging that in the calculator, 23.77 feet. According to the function, that is the maximum height it will reach. And to answer the question, if the bell is 25 feet, no matter how hard someone hits, it's only going to reach this maximum. So will it be hit by the ball? The answer is no. And that's an example of those games at the carnival. They just want to get your money. There's very unlikely that the person will win the prize. All right. Look at this on Desmos so we can see it for ourselves. Here's our function, negative 16 t squared plus 39t. Let's zoom in a little bit here to see this. All right. Here's our starting. We start down there at the origin. Person hits it. Maximum height right here. There it is. Look at that, 23.77. If we wanted to, we could say h of t equals 25. All right, and then if we zoom in even more, we can see that difference between those two functions. If you look closely, they're never going to touch that 25 mark right here. And then there's our 23, there's our max right there, 23.776. All right, third example. Grasshopper with bionic legs leaps from a stump with an initial velocity of 64 feet per second. It's determined that the height of the grasshopper as a function of time can be modeled by h of t equals negative 16t squared plus 64t plus 3. A few questions here. When does the grasshopper reach the maximum height? And what's the height of the stump? And what's the maximum height? Okay. The stump is where he starts. So we can answer that second question. That's going to be t equal to 0. So if we just do h of 0 and plug that in, negative 16 times 0 squared, 0, 64 times 0, 0, and we have that 3. The height of the stump is 3 feet. That answers the first question. Okay, so we got that taken care of. The maximum height and when does it reach the maximum height, that has to do with the vertex. This thing is a upside down parabola. If we find that vertex, we'll find two things. How long it takes to reach the maximum height, that's the x-coordinate, or in this case t-coordinate. And then the y-coordinate will tell us the actual maximum height. So let's go back to our formula for the x-coordinate of the vertex, negative b over 2a. Remember our a, b, and c. A is negative 16, b is 64, c is 3. Negative 64 over 2 times negative 16. Negative 64 over negative 32. That simplifies to 2. Maximum height that the bionic grasshopper jumps happens at 2 seconds. To find the actual height, put 2 in for t into the function. So we have negative 16 times 2 squared plus 64 times 2 plus 3. Plugging that in a calculator, we're going to come out to be 67 feet is how high the bionic grasshopper jumps. Let's jump on over to Desmos and see this in action. All right, I have to zoom out a little bit so we can actually see this. All right, here's where he starts. The stump is 3 feet. We see that right there. Here's our maximum. Click on that. 2 seconds, 2 for the x-coordinate or t-coordinate, 67 for the h-coordinate or height. The height he jumps is 67 for a maximum. There we go. Okay, I hope these examples helped us understand some situations involving applications of quadratics. Thanks for watching.